Hello, and welcome to today's webinar, which offers a demo of the Arduino Engineering Kit. Thank you for taking time out and being here with us. Before we jump in, just a few housekeeping items. We'll be running a live question and answer session towards the end of the webinar. Please feel free to use the chat feature on your participant panel and pop any questions you may have in there, and we will be sure to address them when the time comes. Also, if you miss any part of the content presented today, not to worry, we'll be sending out the on-demand recording when it's available. My name is Pamela Cyphers. I have worked in product development and design for the ed tech industry for more than a decade, and I also currently fill a marketing leadership role with Pisco Education. With me today are three colleagues from Arduino Education that I am very pleased to introduce. The first is Ernesto Lopez. Ernesto is a telecommunications and electronics engineer who specializes in PCB design, robotics, electronics prototyping, signal processing, embedded systems, and control. He has experience in C++, MATLAB, and Simulink programming. Currently, Ernesto works at Arduino as an application engineer and also as the Arduino Engineering Kit product owner. Also with us today is Ali Jahangiri. Ali has a background in physics and is the author of several peer-reviewed articles in nanophysics and materials science. Currently, Ali works at Arduino as a technical writer, developing documentation for the Pro and EDU products. Last but not least, we have Roxana Escobedo. Rox has a background in design, communication, and education. She has experience in researching creative teaching and learning, as well as in designing learning environments for students and children with different learning abilities. Currently, Roxana works at Arduino as an education partner trainer. I would like to personally thank Ernesto, Ali, and Rox for being with us today, and will officially turn the presentation over to them.
Thank you, Pam, and thank you, our partner in the US, Pisco, for putting this webinar together. And thank you all for coming today. This is Engineering Kit REV 2 webinar number 4, the last one. And we're going to show you today project demo, so it's going to be very fun. And as Pam mentioned, today we have Ernesto and Ali as special guests. And this is what we're going to do today. So if you remember, on the engineering kit, we have 3 different projects: the self-balancing motorcycle, the webcam control rover, and the drawing robot. So we're going to take a look at each of the products. We're going to discuss the learning outcomes, like the building process and a demo. And then at the end, we're going to discuss with you further experimentation and some user cases. So what can you do once you're done with the kit, so that you can learn with it. But first, let's take a look at the recap for last webinar, webinar number 3, when we learned everything about the engineering kit platform. So remember that the engineering kit, when you buy the engineering kit, you have access to the software, the hardware, and also the content is on our learning platform, where you will find 3 lessons and 3 projects. So the lessons are very good for experimentation and to explore the different concepts that we introduce in the engineering kit, like mechatronics, robotics, etc. And we have a getting started session where you will find all the installations that you need to do: MATLAB, MathWorks, Simulink, and also some add-ons. And then you also will see all the programming and the theoretical concepts. And also on the project side, you will have all the building instructions for each project, and something very important is that you will have a real-world application applying concepts. And then we also learned last webinar that the content is very flexible and it can be adapted depending on the teacher and students' need. So for each lesson and project, you will have an overview, you will have the learning outcomes, and you will have a video with all the projects. The content is modular, that's why it's also very flexible, as I mentioned before. You can follow the content the way you want. It's not mandatory to follow like in a linear way, like first the motorcycle and then the rover and then the drawing robot. You can follow it as you want. And in the platform is very also easy to navigate. Also, you will find there in the platform some goal setting and times, and this modularity allows you to see how much time allocate to each project. We have some recommendations there. And also it's very easy to swap between experimentation and application. So it's really very good and it's adaptable to different learning styles. So that's what we learned on last webinar. So with any further ado, let's check the demos. So for this first demo, we're going to check the self-balancing motorcycle, and Ernesto is going to present this. So Ernesto.
Okay, thank you, Rox, for the introduction. And yeah, first, we have been talking before about the projects, but the idea in this case is to take a little bit of a closer look to the projects and also show them some videos of the demos on them working, which we have not done before. So with the self-balancing motorcycle, basically this project is a version of the classic inverted pendulum problem. The goal of the project is to design a system that keeps the motorcycle standing using an inertia wheel. One particularly interesting thing about this project is that we get the opportunity to experiment with Simscape, which is a tool that allows us to simulate the balancing system before actually trying it on the physical hardware. As with the other projects in the content, we start with a theoretical approach, trying to understand the problem we're trying to solve. In this case, we have the forces that are applied to the motorcycle, the gravity, and so on, and the vectors of the forces, and also the force that we're trying to apply using the inertia wheel and how that will affect to the current position of the motorcycle. In this project, we're using Simulink for the whole exercises, and on top of that, we're using Simscape, like I said before, and Stateflow, which are two packages that runs on top of Simulink. So the learning outcomes for this project, we touch about how to design a closed loop control. We touch about model-based design, the kinematics of their own problems, and basically a lot of fun in the process. So let's take a look at the video and see it in action. Excellent. So yeah, so what we see here is basically the workflow that we need to follow when we develop the project. So we start with a simulation part, then we continue with calibrating the IMU sensors, and finally we deploy the algorithm that we developed and tested in our simulations in the final hardware, and we can do some performance tests. So thank you, Rox, for showing the video.
Okay, so the next project we have in the AEK is the webcam controlled Rover. So if you could bring, yeah. So the webcam controlled Rover is basically a very simple way to get students engaged in understanding differential cinematics. So instead of having a very abstract notion of motion, students can directly engage with these equations, and through modeling these concepts within Simulink and then applying those in the real world, get a very intuitive understanding of the the motion and then apply these onto further education they have. So one of the features that this project has is that we make use of the toolboxes used in MATLAB and Simulink in order to have an experience working with both closed loop and open loop control. So students can understand the difference and apply them as needed. The main learning outcomes include understanding the differential motions, understanding the cinematics of the rover locomotion, making use of image processing algorithms to identify the location of the rover based on the webcam, and then moving that to a specified location, making use of simulations to better understand the model before it's applied in the real world, and finally making use of wireless communications to be able to remotely connect and control the device. So if you could take a look at the video. Okay, so what we just saw was the full assembly process. As you can see, the complete assembly process is provided on the online platform. And we also saw the PID testing process. And this is possible to be implemented both within MATLAB, Simulink, and the Arduino IDE. As well as the final example was one of the further experimentations that a group of students have done. So you can see that there's a wide range of applications that can be made for this particular use case. Thank you.
All right, so now we're going to talk about the drawing robot, which is the last project in the kit. The drawing robot is actually a very fun project. The goal is to replicate an image from the computer to a whiteboard using a plotter, a robot that moves around. As usual, we start with the mathematical principles that we need to understand and use in order to make the transformation from the pixels of the image we're trying to replicate to the coordinates of the position of the whiteboard, and as well as the number of rotations that the motors need to do in order to locate the robot in a specific position. As you can see, the robot is hanging on the corners of a whiteboard and is using some motors to pull the robot in specific directions. This project is done entirely using MATLAB, and we also teach image processing principles to transform the original image into something that is going to be easier to draw. If we have a too complex image with shadows and things, that's going to be too hard for the robot to draw. So we are applying some filtering algorithms to the image, to the original image, in order to get the contour so the robot can actually display it on the whiteboard in an easier way. So some of the learning outcomes that we have, you can read here. We learn and apply concept coordinate geometry physics. We automate the complete application workflow from start to finish. We learned about the mathematics, the trigonometrics involved in this particular problem. And then we teach, of course, how to code or how to solve a problem using MATLAB. So now we can take a look at the project, at the video demo. All right. So that was the drawing robot, and I guess we can now move to the next slide, in which we're going to speak about the let's say the further experimentation. So one of the things that is very interesting about this kit is its capabilities for expansion. So the kit provides all the tools that you need to keep on exploring on your own once you complete the project. For example, you can reuse the electronics of the kit to build a completely different robot, or you can repurpose one of the existing projects to do something different. In the next video, what we're going to show you is 3 examples of projects that were built aside from the ones that are in the content. And the idea is to show you the expansion capabilities of the kit. So in this video, we're going to see 3 projects. The first one is a tic-tac-toe machine that we developed at Arduino, basically as a showcase. What you're going to see is a tic-tac-toe machine that plays against a user without any assistance from the user. So the code is, the exercise is developed in a way that using the webcam that is included in the kit, we take an image of the whiteboard, and we read the status of the matrix using some image processing algorithm as well, and color filtering, and using a minimax algorithm and knowing the status of the matrix, the robot can take a decision on what is the best move. And based on that, the robot will actually go to position, make his mark, and go back to home, waiting for the user to do the next move. This is a very fun project, and also exploring other sides of robotics and embedded systems. And it's one of the projects we're going to see in the video. The second project is a web application that one of the interns from MathWorks developed, which is basically controlling the rover using his phone. So instead of using instead of doing the exercise that we explain in the content, he basically developed an app to give commands to the Wi-Fi signals on the board and control the robot with his phone. And the last project we're going to see is actually also using the rover, and is let's say a fancy version of a line follower. If you know what a line follower is, basically it's a robot that follows a line. But in this case, we're also using a webcam that is controlled to the computer, and by reading the image in real time, we can basically move the rover trying to follow this line of papers that you will see in the video. So again, this is just to show what capabilities have the kit for further exploration. And in this case, we are mostly using components that are complete, that are all in the kit. But there are, of course, room for other type of exploration, like developing your own robot, maybe doing your own 3D parts. You can reuse the electronics in any way you can seem appropriate for maybe a laboratory session, or a final exam, or a final project for your students. So let's take a look at the video.
Thank you, Ernesto. So we're now going to show several a use case where some of our partners have used our platform for education. And one of its examples is the San Francisco State University, and they made use of our platform. And one of the great features is that because everything is available as an online platform, it's very accessible, and it really reduces the burden on the for the educators, so that it's possible in a distance learning situation to provide mechatronics education, and in this case teaching students about this multidisciplinary field such that they can understand what the electronics, the mechanical design, and in general the overarching system architecture, and to then be able to apply these for their future work. So we can see a video of this in action as well. So this was the drawing robot. You could see when Ernesto presented. And it's not just for education. The Arduino Engineering Kit can also be used as a starting point for research. So in the University of Cauca in Colombia, I think the physics department made use of this as a tool to evaluate control algorithms, in particular the control, in which they saw how the trajectory could be used to optimize the balancing of the robot. So one of the big benefits is that the Arduino Engineering Kit can provide a platform to accelerate the process of research and make sure that it's simple and easy to engage in concurrent simulation and experimentation side by side. So that's that.
Thank you, Ali. I just want to add one more thing regarding the further experimentation and how can professors, let's say, build on top of the things we are providing. One of the things that we have also done, we didn't have the time to show it in video, but we have been also exploring with some of the AI features of MATLAB and Simulink to try to port some of these features into our robots. It's very common to use tools like MATLAB and Simulink to develop AI algorithms, machine learning algorithms. And we have made a demo for example, a self-balancing motorcycle, where we apply linear regression to estimate the torque on the motors to give the right balancing position. And we have also used one of the interns at MathWorks also developed a reinforcement algorithm also on top of the motorcycle. And this is published actually in Project Hub, so you can take a look at these projects. This is again one of the multiple possibilities that are out there to explore on your own once the projects are completed. And the use case of San Francisco University shows also one of the options that professors have to use the kits in now the current situation that where we are facing, where many schools and universities are starting to be more resilient against, let's say, a pandemic, and they're trying to implement or looking for solutions where they need to continue educating their students from in a distant way from home or distance learning. And this is a great scenario of a university using the engineering kit to actually achieve this in this way. So thank you, Ali, for the presentation, and Rox as well. And Rox, you wanna take over?
Yes. Let me go ahead to the video. So if you're interested in the engineering kit or other Arduino products, you can go to PITSCO website and contact Eric Simmons of Brandonville. And as we mentioned earlier, this was the last of the series of webinars about the engineering kit. We hope you find it useful, and I don't know if there's any question there.
So we have not received any questions throughout the course of today's webinar. If anyone has one, they're more than welcome to pop that in there.
Yeah, just remember, as I mentioned at the beginning, when you have the kit, you have access to all that you saw, like the hardware, the assembly pieces, the platform with all the instructions to build everything, to learn the concepts, of course. And as Ernesto mentioned, it's a really good tool to keep teaching and learning from home. And also the whole Arduino approach to learning is also this project-based learning where the student has control, right? So this frees the teacher to keep to give more attention to each student, because as you saw on the platform, we have all the instructions. So that also helps a lot to teachers, so they can focus on each student and help them if they have any issues. So it's a very convenient helping tool to students to keep learning these engineering concepts that sometimes are easy, right? We have, when we run this webinar about the engineering kit before, we have really good comments about teachers that they wish they would have this tool when they were studying the university. So now they can do it even in a remote setting. So it's very helpful.
Rox, we did have a question come through, which is, what is the typical timing of these projects over a semester? Do courses typically do all three plus a final project?
That is a very good question. And normally the experience we have, and I mean, we have different cases of professors adapting the kits to their own particular needs. Some professors, for example, have built a completely new course based on the kit, while other professors just use it as an extra laboratory exercise or laboratory session to complement their already ongoing maybe class, maybe about MATLAB or Simulink. So it kind of depends on the kind of course that you're doing. But that said, normally professors, what they do is they choose one project to run in their class. So normally, since some of the projects touch a little bit different subjects, some professors might be more interested in one particular project rather than the other. So normally what we have seen with professors we have been speaking with, they normally pick one project to develop during their class. So normally professors, for example, take their own lessons about maybe introduction to Simulink or introduction to MATLAB, and then they incorporate the kit as a, let's say, exercise. But like I said before, there are also some professors that are developing a new course, and they are looking for tools to support their course. It could be, for example, like a kind of new technologies course or introduction to new technologies, and they basically are looking for something to completely base the course on. And in that case, they maybe have more time to develop maybe one or two projects and maybe do something on their own at the end of the lesson, at the end of the course.
Yeah, as we mentioned earlier also, as you can see, the kit is very flexible. Of course, we have some recommendations, but once you understand how it works, like when you build your projects, you're being a teacher before implementing this with your students, you can, as Ernesto said, adapting it. So you can do whatever or allocate the time you need according to your own class, the pace of your class, and the experience of your students. So it depends on you. You can adapt it. It's very flexible in that sense.
think that's all the questions that we've received. I would like to remind everybody that if any questions, or if you would like to review the content that was presented today, we'll be sending out a link that will enable you to do so on demand whenever it's convenient for you. So unless Ali, Ernesto, or Rox have any closing thoughts you'd like to share, I think we are ready to close for today.
Yeah, so just if you missed one of the webinars, just watch the recording so you know exactly how to start, how you can get in the box and the learning platform and everything, so you get a better idea. So it's good if you can see all the webinars so you can understand better all the product if you missed the other 3 webinars. And that's it. Again, thank you to Pitsco, Pam, Eric, and Brandon, and to the Arduino team, Leonard, Ernesto, and Ali, for being here and share their experiences with the engineering kit. So thank you so much, and thank you guys for joining during the series of webinars.
Thank you,
Yeah,
everyone.
yeah. Thank you, Pisco, for helping us with these webinars, and thank you everyone that have been watching all these webinars in the last weeks. And hope you find the kit interesting. And of course, if you have more questions to us, just you're more than welcome to write to us, and we'll do our best to answer you. So thank you.
Thanks. Ali, do you have final thoughts?
Yep, thank you. Yep.
Okay.
My pleasure.
Thank you all, and have a good day and a good morning there. And remember, any questions you have, please let us know. And really, we really hope you enjoy the series of webinar and that you find it useful for you and your students. And remember that anything you need, please contact our partner Pitsco, and they will be super happy to help you. And thank you again to Pitsco.